So, you're going on a journey to a black hole. Well, you'll need a lot of provisions, because the nearest black hole is 1011 light-years away. This black pearl was found in the solar system called HR 6819. It was hidden in orbit with two other stars, which you can see with the human eye. Scientists have been studying this system since the 80s, but this winter it revealed its main secret. This particular black hole is considered relatively small, but despite this, its mass is 4 times bigger than our Sun, and it's 2,500 light-years closer to Earth than the next nearest black hole. But don't worry. For people, the distance of 1,000 light-years is unreachable. For example, if we were to make a model where the Earth's distance to the Sun was only 0.05 inches, you would have to travel about 4 miles to get to this black hole. But our galaxy, the Milky Way, is about 100,000 light-years wide, so the distance of 1,011 light-years doesn't seem that long in comparison. But before you jump inside this black giant, let me try to discourage you. A black hole is a place in space-time where nothing can leave its orbit. No particles, electromagnetic radiation, or even photons of light can escape from a black hole. So you should understand that a journey to such a dangerous object as a black hole is a one-way ticket. And the way black holes are born is incredible. When a star runs out of fuel, the star collapses under its own weight and becomes a black hole, like the supermassive black hole in the Messier 87 galaxy. Its mass is 7 billion times bigger than the Sun, and it was discovered by the Event Horizon Telescope in April 2019. Okay, good. I see you've already bought a ticket for a faster-than-light spaceship. Since there's no refunds, and you don't want to lose the money, it's time to get ready for the trip. Oh, feel free to leave your luggage at home. 3, 2, 1, off you go. You're leaving Earth's orbit, saying goodbye to the Moon, and don't forget to cheer up Pluto by saying it is big enough to be a planet. Then you pass the highway of dark space, and here's your stop, the black hole. Put on your suit, because you're going into outer space. The first thing you see is the event horizon. The gravitational field of a black hole bends the light around its edges, so the event horizon is like a croissant for the observer. Once you reach the event horizon, though, you won't be able to get back out. You may also notice that there's some kind of chaos in this ring. Some lights move in different directions. This happens because you get a mirror effect. But we still don't know what's inside the black hole, so you decide to send in a drone first. The gravity field of the black hole quickly draws in your metal buddy. As soon as he enters the event horizon, his body begins to change its shape. It becomes elongated like a strand of spaghetti, and the closer it gets to the center of the black hole, the longer it becomes. You also notice the drone has slowed its movement and now gradually approaches the black hole center. This is another effect of this space monster. The black hole's vast mass curves not only space but also time. If you hang one watch next to a black hole and another on the wall in your bedroom, you will see that in the first watch, the second hand has barely moved, while a whole day has passed on Earth. And the more massive the black hole, the stronger the effect of slowing time. Theoretically, if you have a spaceship that can overcome the gravity of a black hole, you can fly to it and wait for a few seconds. During this time, your friends on Earth would live a whole life. The flashlight on the head of your drone has turned red. This color change has happened for the same reason. The clocks that are deeper in a gravitational well tick slower when observed from outside. This also affects the photon's wavelength. We see red light because it has the longest wavelength of any color in the visible spectrum. All these things actually happen to the drone in a split second, but it seems slow to you because of the time warp. Alright, it's time to enter the black hole yourself. The final preparation is your suit that will protect you from Hawking radiation. This radiation is created by black holes due to quantum effects near the event horizon. Hawking radiation reduces the weight of the black hole, so if the black hole doesn't absorb more mass from nearby objects, it becomes smaller and then simply disappears. Oh yes, the black holes are also mortal. But Hawking radiation can turn you into ash, and you'd lose the chance to see the black hole from the inside. Okay, now let's do what you traveled 1,011 light-years to do. One big jump, and you are caught in the gravity field of the black hole. This is the point of no return. But your distance allows you to set a stable orbit so that you can spin around the black hole like the moon around the Earth. A little higher, and you'll be thrown into infinity. A little lower, and you will be dragged into the black hole. So, theoretically, planets could exist at this distance, and even inhabited if there were the necessary conditions. A couple of minutes later, and you are approaching the event horizon. Oh, look down. Your body is so long. You are now spaghetti yourself. Look around you. The stars are turning blue. This is called gravitational blue shift. As you fall into a black hole, its gravitational field pulls the photons of light down, giving them energy. Their wavelengths are getting shorter, so the red photons change into blue and everything starts to look blue. Now you are right outside the event horizon, and the only thing you can see is a round blue beam of light above you. But soon you will stop seeing even that. So you've survived the strong gravitational field of a black hole, and the Hawking radiation didn't burn you to ash. You are now in the heart of the most mysterious object in the universe. You have front row seats, but the view is not that impressive. This is the darkest place you've ever been to. Even the usual laws of physics just stop working here. Theoretically, time goes by so slowly here that your home planet could no longer exist, and a new black hole could appear in place of our sun, but you will live exactly as long as there's enough oxygen in your suit. But what if this cosmic object is actually a wormhole that leads to another place in the universe? This is a popular theory, but scientists still can't confirm it. But if it is true, then after a while, you'll see a blue light again. Now you'll experience the same fall, only in reverse. Once you leave the singularity, which means the black hole's heart, you will be in the event horizon. The light from the stars gradually changes from blue to red. You can feel the shaking and warmth from the Hawking radiation. But then you are thrown into outer space, perhaps in some faraway galaxy. No one knows what will happen next. Are you in contact with an unknown life form? Or will the conditions there be intolerable for a human being? Or maybe you will not go to another place in space, but to a parallel universe. This theory also exists. According to it, black holes are portals to other dimensions. Simply put, there are endless copies of our universe. Every time you were faced with a choice, your twin from another universe chose something else. But let's leave that to fantastic movies. Right now, the journey into a black hole is merely impossible for humanity. We can't even reach the nearest one. But one day, we will learn more about these space objects' nature, and maybe this knowledge will push humanity forward and make us a multi-galactic civilization. Dark, ever-hungry monsters live all across the universe. They're born when massive stars blast into space. Black holes, as heavy as Earth, are just as large as a ping-pong ball. They don't have a surface, but their gravity is so strong even light can't escape it. Black holes don't have physical boundaries like a membrane either. The event horizon, which is closest to a typical boundary, is a threshold which, after passing, you can't get out. For a star, running into a black hole normally ends in a spectacular light show and its destruction. Just one star that astronomers know of managed to survive an encounter with a black hole as heavy as 400,000 suns. It happened in a galaxy about 250 million light-years away from Earth. Astronomers with really powerful equipment noticed bursts of X-rays that raged in space every 9 hours. They thought they must be Mayday signals from a star trapped by a cosmic abyss. The star was an average red giant when it met its new friend for the first time. When they got too close to each other, the hungry space monster couldn't resist the temptation and snacked on its guest. When it was done with the star's outer hydrogen layers, all that was left was the star's core. Eventually, the poor thing turned into a white dwarf. But for some reason, the giant space monster couldn't finish the meal and trapped it in its orbit for later instead. Ever since, the now white dwarf has been traveling in 9-hour laps. It stays far enough from the hole so it won't fall in or get swallowed. Its journey isn't going super smoothly. Because of gravity, the orbital path is constantly rotating. After 2 days, it resembles a spirograph pattern. As the black hole keeps snacking on it, the star keeps losing its mass and growing in size. Its own orbit is becoming more and more circular. Scientists believe one day it will be able to spiral away from its mean friend and turn into a planet the size of Jupiter in 1 trillion years. That's 70 times longer than the universe has existed so far, so it might not ever happen. The Milky Way alone has hundreds of millions of black holes, and there are way more beyond it. They might feed on other stars and release them in other galaxies. The telescopes that exist now might not be strong enough to spot them. Most galaxies, including our Milky Way, have supermassive black holes at the center. They can be billions of times heavier than the Sun. Others of their kind are only 3 times the mass of the Sun. The nearest black hole to the Earth was spotted 1,000 light-years away, just around the corner in galactic terms. It's in a star system you can see with an unaided eye. Scientists found it when they noticed a star behaving weirdly. It was a giant, rotating like crazy. They guessed it must have a powerful gravitational companion. The hungriest black hole astronomers have spotted so far weighs as much as 34 billion suns and is about 6 times bigger than the one at the center of the Milky Way. It eats the equivalent of 1 sun every day. Sometimes black holes even devour others of their kind that happen to be too close to them. Before you get on a spaceship to escape to some safe, no-black hole galaxy, here's some good news. Even though they're supermassive, they don't have a radius large enough to destroy Earth. And even the hungriest of them are safe to watch from a distance. No black hole should come closer to our planet than the Sun for as long as the universe has existed, multiplied by 10 billion times. In the unlikely case one of these scary things passes by Neptune, it could affect the Earth's orbit. That would be no good. In theory, anything can turn into a black hole. The only difference between it and the Sun is the material their centers are made of. It's incredibly dense in those huge space monsters. In reality, there's just one known way to make a black hole. It has to be the gravitational collapse of a supermassive star, 20 to 30 times the mass of the Sun. So, the Sun will never ever become a black hole. If it happened, though, and the former star retained its mass, it would still have the same gravitational power. Earth would still keep going around it and wouldn't get pulled in. Its orbit would also remain as it is. The only huge problem would be the lack of sunlight. In reality, the Sun isn't massive enough for such a transformation and will eventually become a white dwarf. A black hole won't ever eat an entire galaxy for lunch. There are about 400 billion stars inside the Milky Way. Just around 0.1% of all the stars that will ever form will end up becoming black holes. The ever-hungry supermassive monster, located right in the middle of a galaxy, has an impressive gravitational reach. But even that wouldn't be enough. It has already eaten most of the stars that were close to it. It already weighs like a few million suns, so it can't grow much larger even if it keeps snacking on sun-like stars. Galaxies will keep bumping into each other, and black holes will keep growing and merging. But because the universe is already huge and keeps expanding, these collisions and mergers won't go on forever. Black holes will travel this huge space like rogue stars. They won't even be able to eat the dark matter on the outskirts of galaxies. Eventually, all the black holes will perish, but that would be a long, long time from now. If you ever become a space explorer and travel far enough to meet a black hole and fall into one, your life won't instantly end. Instead, things will be way more complicated. The way you perceive space and time will change, and your reality will split in two. In one of them, you'd cease existing. In the other, you'd live and enter the hole unharmed. When you go deeper inside the hole, you'll notice space becoming curvier and curvier. At the center of the hole, it's infinitely curved. It's called singularity. Laws of physics based on the ideas of space and time don't have power here. In a large enough hole, millions of times more massive than the sun, things would go perfectly smoothly for you. And you just keep free-falling, feeling no gravity. You could just keep falling and falling in total emptiness until you reach singularity. You'd have no chance to move in the opposite direction. In there, space and time switch roles. Time is constantly pulling you forward on Earth, but figuratively, and it would be doing that quite physically inside the hole. In a smaller hole, the force of gravity would be stronger at your feet than your head. That's why you would go through spaghettification. This is how scientists call the process when you compress horizontally and stretch vertically like spaghetti because of crazy gravity of the black hole. Speaking of spaghetti, how are black holes like an Italian dinner? Because once you go pasta the event horizon, you get spaghettified, and since you're all by yourself, you'd be feeling cannelloni right now. Wow, now I'm hungry. Meanwhile, if you had a fellow space traveler who, for some reason, didn't end up in the black hole, it would look all different to them. They'd see you stretch and grow, like through a huge magnifying glass. The closer you get to the edge of the hole, the more it would seem like you're moving in slow motion. Then you'd freeze, and the flames would surround you. You'd be in two places at the same time, living different destinies, but there would still be just one copy of you. This is how black holes teach us nothing is real. Reality can be different to different people. Some scientists believe that we're all living inside a huge black hole. Everything in the universe started with the Big Bang. But there's a theory saying there was also something before that. It was a super dense seed that had all the mass and energy of the universe concentrated in it, about as heavy as 1 billion suns. It was 1 trillion times smaller than any particle humans can observe. This seed could be born inside a black hole. If you believe there's more than one universe, black holes could also serve as doors between those universes. It could be like a root that two trees share. You can't see a black hole directly because it doesn't give off any light. Scientists used to be able to only spot them by what they were doing to their surroundings. When over 200 scientists around the world worked together, they managed to take the first pictures of that space oddity. The equipment they used, added together, would be the power of a telescope the size of Earth. Not so long ago, astronomers discovered a planet that got the name of UCF 1.01. This world is about 33 light-years away from Earth. This makes the planet our next-door neighbor, in the cosmic scheme of things, of course. Honestly speaking, the space body is only a planet candidate because astronomers haven't measured its mass yet, but they have high hopes. The wannabe planet is very different from our Earth. Just 1.7 million miles away from its star, it completes its orbit in a day and a half. It's a scorching, deserted world with the temperatures at the surface rising up to 1,000 degrees. Even more astounding, the entire planet is likely to be covered in magma. Even if UCF 10 ever had an atmosphere, it has definitely boiled away by now. But then, the question is, what if Earth once went through some catastrophic event and it left our planet in the same state, boiling hot with the surface covered by a thick layer of lava? Would people manage to adapt to such conditions and move to live underground? It sounds unbelievable, but experts are sure that with time, humans would turn into healthy and rather happy mole people. Of course, life would be very different than today. No more sunsets and sunrises. No more traveling by plane and space exploration, unless people found a way to launch a rocket from under the ground. No more picnics in the park or sunbathing at the seashore. People would have to build a vast network of underground tunnels that would connect major cities. The most likely transport in this new world would be silent high-speed trains and electric cars. After moving underground, people would have not only physical but also psychological difficulties. In the beginning, their new home would be a dark, barren place, without fresh air and devoid of any color. To adapt to these tough living conditions, people would have to make some design changes. Greenhouses, well-lit parks with trees and illusions of the sky, familiar scents and sounds. All this would help people to adjust to their new life. After living underground for several generations, people would start to look a bit different. Pale because of the lack of sunlight, with sensitive large eyes adapted to dimmer lighting and more developed lungs. As for the very possibility of living underground, well, hear me out. You might imagine the Earth's depths as a huge mass of compressed solid rock. But the reality is different. This mass is heavily cracked. Water runs down the fractures and cracks in the planet's outer layer, the crust. Some of these streams reach the depth of many miles. In other words, subsurface Earth could probably support plant and animal life. If people lived underground, they wouldn't have a shortage of fresh water. Its reservoirs in the planet's interior contain 100 times more water than all the lakes, rivers, and swamps combined. Plus, this water trickles through the soil that acts as a purifier. But people would have to be super careful to keep the sources of water intact. Otherwise, the underground cities would get flooded and turn into giant water-filled traps. It would also be a great challenge to live without sunlight. Plants can't survive without the sun's ultraviolet light. It's absolutely necessary for photosynthesis because sunlight is used to get nutrients from carbon dioxide in water. One of the byproducts of this process is oxygen, the thing people can't live without. So, no sunlight equals no plants equals no oxygen. Sunlight is also crucial for humans. For example, it helps your brain release serotonin, a hormone that boosts your mood and makes you feel focused and calm. Thanks to the ultraviolet B radiation in the sun's rays, your skin produces vitamin D. It's vital for a strong immune system and healthy bones, teeth, and muscles. That's why people would have to find a replacement for sunlight. Luckily, LED lamps that can give off UV wavelength could produce the light human bodies and plants crave so much. In the new underground world, there wouldn't be large sunlit fields. Instead, there would be sprawling greenhouses with LED lights shining from the ceiling. Special machines would feed plants and crops with recycled water rich in nutrients. In some areas, located in the narrow underground faults, people would use something like shipping containers instead of greenhouses. These containers would be packed with vertical rows of plants and blue and red LED bulbs. As for people, they would have to follow a vitamin D-rich diet. It'd mean eating a lot of egg yolks, cheese, fish, spinach, soybeans, and so on. If these foods weren't enough, vitamin D supplements would do the trick. Without daylight, people would have problems with their circadian rhythms that regulate sleep patterns. If you were isolated somewhere without a glimmer of light, you would easily sleep for 48 hours at a stretch. That's why people living under the Earth's surface would rely on artificial lights to control their internal clock. There wouldn't be any problems with electricity. It would be produced with the help of the Earth's inner heat. Such kind of energy is called geothermal, from the Greek words geo, earth, and therm, heat. It can be extracted from hot water and rocks. Like an onion, our planet is made up of several layers. The innermost part is a solid core around 1,500 miles across. Made of iron, it's surrounded by a scorching outer core. It's up to 1,400 miles thick and is mostly composed of liquid nickel and iron. The next layer is the mantle. Even though lots of people picture it as lava, the mantle is actually rock. But this rock is so hot that it flows, just like road tar. The temperature in the Earth's core is as high as 10,800 degrees Fahrenheit. That's almost 1,000 degrees more than at the Sun's surface. The mantle is also blistering, from 7,000 degrees at the boundary with the core to 400 degrees in its outer parts. No wonder people wouldn't have any difficulties with transforming all this heat into electrical energy. But because the insides of our planet are insanely hot, people wouldn't be able to build cities too deep underground. All inhabitable areas would most likely stay closer to the surface. The Earth's outermost part, the crust, is like the shell of a hard-boiled egg. It's broken into gigantic blocks called tectonic plates. When two plates collide, mountains get formed and new rifts appear in the seafloor. They have different width, from 25 miles thick beneath the continents to 5 miles thick beneath the oceans. These blocks travel around, floating on the Earth's mantle, slowly, almost imperceptibly. It means underground cities would also move, but it would be next to impossible to notice these movements. Oh, by the way, people started to believe there might be another world inside our planet in the 17th century. The idea got the name of the Hollow Earth theory. It claimed that half the planet was taken up by its surface weight. Below the surface, there was some empty space. A small sun hung at the very center of that cavity, creating a comfortable tropical environment on the inner side of Earth's surface. One could enter the Earth's interior through one of the openings near the South and North Poles. A race of advanced humans was believed to live inside the planet. They were peaceful and lived for centuries. Well, obviously not humans. They had unique technologies, for example, flying vehicles. And since the climate inside the planet was better than that on the surface, this race was much stronger and healthier. Even though this idea sounds like science fiction, several famous scientists supported it. Some people are still sure there's another world inside our planet. But if the Earth was hollow, it wouldn't have a magnetic field. And without a magnetic field, solar winds would rid our planet of its atmosphere in the blink of an eye. This would leave our green planet deserted and uninhabitable, like Mars is. The magnetic field on our planet exists thanks to the processes going on in its very much not hollow center. Liquid metals are constantly moving in the Earth's outer core, generating electric currents. When the planet rotates around its axis, the electric currents form a powerful magnetic field. The sunward side of the magnetosphere is as large as 10 Earth's radii, and the other side stretches out in a magnetotail that spreads for 200 times the Earth's radius.